Hello everyone, this is Abhishek Mahanti and you are watching Padarth Vigyan. So students, welcome to lecture number 1 of the chapter Electrostatic Potential and Capacitance. In this lecture, we will discuss about what is the meaning of electric potential, what is the meaning of potential difference, and finally we will derive a mathematical expression for the electric potential due to a point charge. So let's get started. So students, in class 11 in the chapter gravitation, we had discussed that if we have two bodies having masses m1 and m2, and if r is the separation between them, then the gravitational force between these two masses is given by F equal to g m1 m2 by r square. Similarly, in Coulomb's law, we had discussed that if we have 2 point charges carrying charges q1 and q2, and if r is the separation between them, then the Coulombic force or the electrostatic force between these two charged particles is given by F equal to 1 by 4 pi epsilon naught q1 into q2 by r square. So if you look at the two equations, they look similar. This is Fg means the gravitational force, and this is Fe, the electrostatic force. So here we have a constant g, and here we have a constant 1 by 4 pi epsilon naught, and then we have the product of the two masses m1 into m2, and here we have the product of the charges q1 and q2, and both these forces they obey the inverse square law of distance. So the force of gravitation between two masses is similar to the force or the electrostatic force between 2 point charges. And in the chapter gravitation, we have discussed about what is the meaning of gravitational potential, and what is the gravitational potential energy of a body. Gravitational potential and gravitational potential energy of a body. Remember that the gravitational force is a conservative force, and similarly this electrostatic force is a conservative force. So what is the meaning of conservative force? We have already discussed it in class 11 that conservative force means the the work done by the force work done by the force moving a body from one point to another point, from one point to another point, is independent of the path followed, is independent of the path followed. It means when you are displacing a body inside a conservative force field, then the work done by that conservative force does not depend on the path followed. It only depends on it only depends on the initial and final point. Initial and final point. Is that clear? Similarly, we'll see that if we move a point charge, a test charge inside an electric field from one point to the other point, then the work done by the electrostatic force will not depend on the path followed. It will depend on the initial point and the final point. It means electric field or electric force is also a conservative force, and potential is the property of every conservative force or every conservative field. So we had discussed about what is the meaning of gravitational potential, and we know that if we have a mass m, then at a distance r from it, the gravitational potential V is given by minus g capital M by r. We had derived this expression in class 11. And if another test mass is placed at that position, then the gravitational potential energy of this mass small m is given by U equal to minus G capital M into small m by R. It means mass into the potential at that point. Similarly, in this chapter, we will discuss about what is the electrostatic potential at a given point and what is the electrostatic potential energy of a charged system. Suppose remember that when a mass is placed inside the gravitational field, it acquires a gravitational potential energy. Similarly, when a charge when a charge is placed inside an electric field then it acquires electric potential energy. It acquires some electric potential energy. Is that clear? The electric field may be produced by a point charge, or it may be produced by a line charge, or it may be produced by a charge sheet. But when a charged particle is placed inside an electric field, then it acquires some electrostatic potential energy. So we will derive what is the expression for electrostatic potential energy in the upcoming classes, but today we will first define what is the meaning of electric potential and what is the meaning of potential difference, and then we will derive the expression for the electric potential due to a point charge. So first I will write what is the definition of electric potential. What is the definition of electric potential? Remember that electric potential is a scalar quantity, and this is the property of electric field. So when we are studying electrostatics, means we are studying the different nature, different behavior of charges at rest. Then we talk about the force between 2 point charges given by Coulomb's law. We talk about electric field. So this electric force and electric field, they are vector quantities, means they have magnitude as well as direction, but electric potential is a scalar quantity. So we also take the help of this scalar quantity to study the electric behavior of a charge. And since electric potential is a scalar quantity, it only has magnitude. So in a more simple way, we can study the behavior of electric charge at rest. So I will first define what is the meaning of electric potential, and then we will go to derive the expression. So remember that electric potential at a point, inside an electric field, inside an electric field is defined as the amount of work done is defined as the amount of work done in bringing a unit positive charge from infinity to that point, So we always define the electric potential at a point inside an electric field. If electric field is not present, then we cannot find electric potential. So to find electric potential, we need an electric field. So we will choose a point inside an electric field, and then we have to find the electric potential at that point. Then how to find it? It is defined as the amount of work done in bringing a unit positive charge from infinity to that point. So what is the meaning of infinity? Infinity means the distance at which the electric field is 0. the distance at which electric field is 0. So remember that infinity refers to the distance at which electric field is 0. So we will bring a unit positive charge from infinity to the point at which we want to calculate the electric potential, and in that process what amount of work is done, we have to calculate it. Suppose let consider that w amount of work, consider w amount of work is done to bring a charge q naught. This is a test charge. Consider w amount of work is done to bring a charge q naught from infinity to a point inside an electric field, then what is the work done by bringing unit positive charge? Remember that to bring a charge q naught from infinity to the given point, we did w amount of work. So to bring unit positive charge, what is the amount of work done? The amount of work done will be w by q naught, and this work done per unit positive charge is nothing but the electric potential, and its symbol is V. So V is equal to W by Q naught, or I can write that electric potential is equal to work done W divided by the charge Q naught. Which charge? The charge which is brought from infinity to that point. So you have to divide work done with the charge. Is that clear? So this is the formula for the electric potential. Now we will talk about what is the meaning of potential difference between 2 points. So the next definition is what is potential difference. Potential difference means we have to find the difference of potential between 2 points. Suppose inside an electric field we have 2 points A and B. We have 2 points A and B. We have to find what is the potential difference between these 2 points. So how to find it? So potential difference between 2 points is defined as the amount of work done to move a unit positive charge from one point to the other point. Remember that potential difference between two points is defined as the work done in moving a unit positive charge from one point to another point, This is the definition of the potential difference between 2 points. Suppose assume that we are interested to find the potential difference between the 2 points A and B. So we will move a test charge q naught from A to B. And suppose in that process the work done is WAB. WAB amount of work is done to displace or to move a test charge q naught from A to B. Then what is the work done to move unit positive charge? So to move a charge q naught, work done is WAB. So to move a unit positive charge, the work done will be WAB by q naught, and this value is known as the potential difference between the 2 points A and B. So if you look at the general formula for the electric potential and potential difference, both are similar. Electric potential means the potential difference between the given point and infinity. But when the 2 points are at finite distances, we use the term the potential difference. So basically, electric potential and electric potential difference both have the same unit and same dimension, because both are expressed in terms of work done per charge. So if I ask you what is the SI unit, what is the SI unit of potential? SI unit of electric potential or potential difference. SI unit of electric potential or potential difference. Then the unit will be work by charge, V equal to W by Q naught. So work is expressed in terms of joule and charge is expressed in terms of coulomb. So the unit will be joule per coulomb or JC inverse. And this joule per coulomb has a special name. This is known as volt. Remember that the SI unit of electric potential is volt. So I can define 1 volt as 1 joule by 1 coulomb. 1 joule by 1 coulomb is equal to 1 volt. So students, remember that the potential difference between 2 points is said to be 1 volt if 1 joule of work is done to move a charge of 1 coulomb from one point to the other point. So let me write the definition of 1 volt. Define, the question is define 1 volt. Define 1 volt. How can I define it? The potential difference, the potential difference between 2 points, the potential difference between 2 points is said to be 1 volt if 1 joule of work is done to move a charge of 1 coulomb, to move a charge of 1 coulomb from one point to the other, from one point to the other. Is that clear? So this is the definition of 1 volt. Now tell me, what will be the dimension of potential difference or potential? The dimension of potential will be how much? So V is equal to W by Q or Q naught. So the dimension of potential or potential difference will be the dimension of work divided by the dimension of charge. So dimension of work is M1 L square T minus 2 divided by charge is A1 T1. So the answer will be M1 L square T minus 3 A minus 1. So this is the dimension of the potential difference. So students, I hope that you have got some idea about potential and potential difference. So now we will go to solve or we will go to derive the expression for the electric potential due to a point charge. So now let us derive a mathematical expression for the electric potential due to a point charge. Suppose we have a point charge Q located at the point O, and we want to find the electric potential due to this charge Q at a distance r from it. So I'll choose a point P which is at a distance r from the point O. So according to definition, electric potential at point P is defined as the amount of work done in bringing a unique positive charge from infinity to this point. So again, infinity means the distance at which the electric field due to this charge Q is 0. Suppose I'll assume that this point is infinity. Now I will bring a test charge Q naught from infinity to the point P. It means initially the test charge Q naught was at infinite distance from the point O, and finally I will bring the charge Q naught to the point P, which will be at a distance r from the point O. Is that clear? So when the test charge Q naught was at infinity, there was no electrostatic force acting on it due to the charge Q, because at infinity the electric field is 0, so there will be no electric force. Is that clear? So when the charge Q naught is gradually approaching towards the point P, at a certain time it will enter inside the electric field of the charge Q, and we have taken that this charge Q is positive and test charge is also positive. Then what will happen? This test charge Q naught will experience a repulsive force. Is that clear? The test charge Q naught will experience a repulsive force. It means some external force should be applied on Q naught to take it towards the point P, because the test charge Q naught cannot go on its own to the point P because it will experience a repulsive force. It means we have to apply some external force in order to move the test charge Q naught to the point P. And remember that we have to move the test charge Q naught without any acceleration. Let us move Q naught from infinity to point P without any acceleration. Without any acceleration. So without any acceleration means what? If this is the test charge Q naught, then it will experience a repulsive force due to this positive point charge in this direction. This is the electrostatic force. So in order to move it without any acceleration, we must ensure that the net force on the charge Q naught is 0. And we have to apply another force which is equal in magnitude but opposite in direction to the electric force. So the applied force Fa should be equal to Fe, and both of them will be in opposite direction. So Fa vector is equal to minus of Fe vector, and these two forces will cancel each other. The net force will be 0, the acceleration will be 0, and the charge Q naught will move with a uniform speed. Is that clear? Suppose assume that during its journey at a certain instant of time, the test charge Q naught is at this point. This is point A. And suppose assume that the point A is at a distance x from the charge Q. So at this position, what is the electrostatic force acting on it? The force is 1 by 4 pi epsilon naught Q into Q naught by x square. And this electrostatic force is acting towards right. Is that clear? The force is acting towards right because it is the repulsive force. But in order to move the test charge towards the point P, we have to apply equal amount of force towards left, so that the charge will move without any acceleration. Is that clear? Okay. Now, suppose I will displace the charge Q naught from point A to the point B, from point A to the point B, such that these 2 points are separated by a small distance dx. The distance between A and B is dx. So, the electrostatic force Fe is given by 1 by 4 pi epsilon naught q naught by x square, and this is towards right, and we are displacing the charge towards left, means against the electrostatic force. The displacement dx is opposite to the electrostatic force. Now tell me, what will be the small amount of work done? Small amount of work done by the electric force, small amount of work done by the electric force when the charge q naught, when the charge q naught is displaced, when the charge q naught is displaced from A to B by a small amount dx, by a small amount dx against the electrostatic force or against the electric force. What is the small amount of work done? We know that work done is the dot product of force and displacement. So it will be the dot product of the electrostatic force dot the displacement is dx. And we saw that the electrostatic force and displacement are opposite in direction. So I can write Fe dx cos 180, and cos 180 is minus 1. So I can write minus Fe into dx. And what is Fe? Fe is 1 by 4 pi epsilon naught q naught by x square, and here you have to multiply dx. So for the small displacement dx from A to B, the work done by the electrostatic force is this much. Is that clear? Now tell me, what will be the total work done in bringing or in moving the test charge q naught from infinity to the point P? The total amount of work done, total amount of work done in moving the charge q naught from infinity to the point P will be W equal to integration of dw 0 to W. The limit will be 0 to W. And what is dw? dw is minus of 1 by 4 pi epsilon naught q naught by x square into dx, and the limit will be infinity to r, because initially the test charge q naught was at infinite distance from the uh, point charge q, and finally it will be taken to the point P, which is at a distance r from the point charge q. So the limit of the distance will be infinite to r. So that will be equal to minus integration infinity to r. Now you can take these constant terms like q naught by 4 pi epsilon naught outside, and you have 1 by x square dx. The limit is from infinity to r. So 1 by x square is same as x to the power minus 2. So that will be equal to minus q naught by 4 pi epsilon naught. You will get x to the power minus 2 dx integration infinity to r. That is equal to minus q naught by 4 pi epsilon naught, and this integration will be x to the power minus 2 plus 1 by minus 2 plus 1. The limit will be infinity to r. That is equal to minus q naught by 4 pi epsilon naught. It will be minus 1 by x. The limits are from infinity to r. Now you can take this negative sign outside, so you will get plus q naught by 4 pi epsilon naught 1 by x. The limits will be infinity to r. So finally we got that w is equal to how much? q naught divided by 4 pi epsilon naught. Now you have to put the limit. First put the upper limit r in place of x. So you will get 1 by r. Then give a negative sign and put the lower limit infinite in place of x. So we will get 1 by infinite. So 1 by infinite will be 0. So we got that w is equal to 1 by 4 pi epsilon naught q into q naught by r. So we have finally derived the expression for the work done by bringing the test charge q naught from infinity to the point P. Is that clear? But what is potential? Electric potential is equal to W by Q naught, work done per unit positive charge. So if W is this much, then W by Q naught will be how much? 1 by 4 pi epsilon naught Q by R. So this is the mathematical expression for the electric potential due to a point charge. The value is V equal to 1 by 4 pi epsilon naught Q by R. Remember that electric potential is a scalar quantity. Electric potential is a scalar quantity. Electric potential is a scalar quantity. It is positive, means the electric potential is positive for a positive charge and negative for a negative charge. If we have a positive point charge, then the electric potential due to it will be positive, and if we have a negative point charge, then the electric potential will have a negative sign. And we got that the electric potential due to a point charge varies inversely as the distance from it. V is inversely proportional to R. Means if you draw a graph between electric potential and the distance, then you will see that the potential will decrease with distance. Is that clear? So students, we have finished the derivation. So in today's class we had discussed about what is the meaning of electric potential, what is the meaning of potential difference, what is the unit and dimension of potential, and what is the expression, the mathematical formula to calculate the electric potential due to a point charge. Hopefully you have understood everything that has been discussed in this class. If you have any doubt, then you can ask me in the comment section. In the next class, we will discuss about the electric potential due to an electric dipole. So till then, have a nice day and bye bye.